Have you ever been cruising down the highway, maybe running a little late, and you get stuck behind one of those massive, slow-moving 18-wheelers?
Oh, yeah, definitely. We've all been there.
Right, and you're just sitting there, staring at the back of this giant metal box, assuming it must be packed to the absolute brim with heavy cargo, right? Like, that's why it's moving so sluggishly.
I mean, it is the completely natural assumption to make. You see a 53-foot trailer dominating the lane, and you just assume it's hauling its maximum physical capability.
Exactly. But a major study of heavily loaded trucks, the ones traveling across those weigh-in-motion scales, it completely shattered that assumption for me.
Oh, really? What did the data show?
According to the data, a staggering 91% of those trucks are nowhere near their maximum legal capacity.
Wait, 91%?
91%. Like 9 out of 10 trucks you pass on the highway are essentially hauling a whole lot of empty air.
Wow. That is just, I mean, when you scale that up to the millions of freight shipments moving across the country every single year, that empty air represents a massive hidden inefficiency.
It's huge, yeah.
The environmental and economic toll of just, moving unused space around is astronomical.
And that is exactly what we're getting into today. We are pulling from a really fascinating stack of sources to figure out how this happens and, more importantly, how it's actually being fixed.
Right, because it is a fixable problem.
Totally. So we've got logistics white papers, some very revealing expert interviews, and these case studies featuring supply chain software from Provision A. We're decoding the max load strategy, figuring out how to master the infamous California kingpin rules, and exploring how advanced AI is fixing a billion-dollar blind spot by solving what they call the physics of moments.
It's a great lineup of topics.
Okay, let's unpack this, because I think people really need to understand the scale here.
Yeah, setting the baseline stakes here is just crucial. Because in logistics, wasted trailer space is not just a frustrating metric for some warehouse manager.
Right.
It is actually one of the primary drivers of excess carbon emissions and inflated consumer prices across the entire global economy.
Because you're paying to move nothing.
Exactly. Paying for the fuel, the labor, the mechanical wear and tear to move empty air means that cost gets baked directly into the price of the goods you buy at the store.
Well, the intuitive solution seems so simple, right? Like, just fill the trucks all the way to the ceiling.
If only it were that easy.
Right, but the reason 90% of trucks are underloaded comes down to a really confusing web of state laws dictating the physical geometry of a loaded trailer.
Oh, the regulations are a nightmare.
Yeah, and for anyone moving freight across the country, the nightmare usually starts with the strictest regulations of them all, which of course is California.
Always California. The regulatory landscape really dictates everything. For context, the standard federal limit for a typical 5-axle U.S. tractor trailer on the interstate system is 80,000 pounds.
Right, 80,000 pounds. And since everyone in the industry knows that cap, the issue isn't really the total weight.
No, not at all.
The bottleneck is how that weight is legally allowed to be distributed across the axles, to prevent roads and bridges from just being completely destroyed.
Precisely. Individual states have their own strict rules on weight distribution, and California enforces a specific axle placement regulation, which, by the way, is often mistakenly called the California Bridge Formula, but it is actually a kingpin law.
A kingpin law, okay.
Yeah, it mandates that the rearmost axle on the trailer can be no more than 40 feet from the trailer's kingpin. And the kingpin, just so we're clear, is that heavy steel pivot pin at the front of the trailer that locks into the truck cap.
Okay, so on a standard 53-foot trailer, California is essentially forcing companies to slide those rear wheels, the tandem axles, significantly forward.
Right, tucking them much deeper under the box of the trailer.
Exactly. And the best way to visualize the chaos this causes is to picture a playground seesaw.
Oh, I like that analogy.
Yeah, so the tandem axles act as the fulcrum of that seesaw. If you push the rear tandem axles forward to meet California's 40-foot rule, you are physically moving the fulcrum closer to the middle of the board.
Right, which completely changes the balance.
Exactly. That single adjustment dramatically shifts a massive amount of weight onto that rear axle and actively lifts weight off the front kingpin. You completely alter the physics of the entire vehicle.
What's fascinating here is how this single-state regulation creates a compounding ripple effect across the entire national supply chain.
Because the trucks have to cross state lines.
Exactly. Because loading a truck to meet those precise axle weight constraints is so complex, it creates absolute paralysis on the loading dock. I mean, a warehouse loader driving a forklift can't simply look at 30 different pallets of varying weights and intuitively know how the seesaw will balance once those axles are slid forward.
It's impossible. So they end up relying on what the industry calls tribal knowledge.
Tribal knowledge.
Which
Remember.
is essentially just educated guesswork, like rules of thumb passed down from veteran workers to the new hires. And the penalty for guessing wrong is pretty severe, isn't it?
Oh, it's brutal. If a truck hits a weigh station in California and that rear axle is even slightly over the limit, the carrier faces massive fines.
Yikes.
Not to mention expensive mandatory unloading fees and totally blown delivery schedules.
So to avoid those penalties, companies systematically terrify their loading dock workers into playing it safe. Like the default solution becomes artificially lowering the payload targets, right?
Yeah, shippers intentionally leave the trailer partially empty. They sacrifice revenue-generating space just to give themselves a massive safety margin.
Which perfectly explains that 91% statistic we talked about at the start.
Exactly. They are deliberately shipping empty air because human intuition simply cannot calculate the precise balance required.
Right. Tribal knowledge completely fails at balancing a shifting 80,000-pound seesaw, especially when the geometric rules literally change the second a truck crosses a state line.
It's a mathematical nightmare.
So moving past human guesswork means bringing in some heavy computational math. And the sources call it the physics of moments.
Yes, the physics of moments. This refers to the actual mechanical calculations required to determine exact axle weights.
Okay, break that down for us.
Sure. So a moment of force is calculated by multiplying the weight of an object by its distance from a pivot point. In this case, the pivot points are the axles.
Got it.
So it is not enough to just know a pallet weighs 2,000 pounds. You have to know the exact moment of force that specific pallet exerts when it's placed exactly 12 feet from the kingpin versus, say, 24 feet from the kingpin.
That is way too much math to do in your head on a loading dock.
Way too much.
And before modern AI, the legacy software that companies use to plan these loads seems incredibly primitive by comparison. I mean, the old systems basically relied on simple grade school algebra.
Oh, absolutely. They would just sum up the total weight of the pallets, sum up the total volume, and if both numbers were under the maximums, the software would just greenlight the load.
Which completely ignores the Seesaw problem.
Exactly. Those legacy builders had absolutely no concept of the physics of moments. They couldn't tell a loader if placing a dense pallet of liquids in the fourth position on the floor would cause the rear tandem axle to bust the legal limit once the truck hit the highway.
Wow.
They merely confirmed that the puzzle pieces fit inside the box with zero regard for the legality of the weight distribution.
And this is where Provision A's software, Auto02, just completely changes the game.
Yeah.
The sources describe it as acting like an execution compass.
An execution compass. I love that term.
Right. Because it isn't just doing simple addition. It's running a simultaneous optimization algorithm. It processes over 300 different constraints at once.
300! That's incredible.
Yeah. It's evaluating the axle laws for every single state on the truck's route, analyzing the specific physical dimensions of the trailer, and even calculating the crush resistance of the products to ensure nobody is, stacking heavy engine blocks on top of fragile glassware.
And it is doing all of this by running thousands of simulated loading configurations in fractions of a second. The AI uses genetic algorithms to test millions of potential pallet placements.
Millions.
Millions. It checks the sum of the moments for the entire trailer in real time, while also factoring in the physical sequence of how a human being actually needs to drive a forklift to pick the goods in the warehouse.
Okay, but wait, let me push back on this for a second.
Sure, go ahead.
If the software is running millions of physics simulations and checking 300 variables simultaneously, so what does this all mean for the poor guy on the dock driving the forklift on a Tuesday morning? Does he suddenly need an engineering degree to read these physics calculations on the fly?
Oh, not at all. That is actually the most elegant part of the whole solution. The dock worker never sees a single equation. The genius of Auto02 is how it translates high-level physics into intuitive execution on the floor.
So how does it actually tell them what to do?
It converts all of that complex optimization into simple, step-by-step 3D visual diagrams directly on the worker's RF scanner. The handheld barcode reader they already use to track inventory.
Oh, wow. So it's acting like an air traffic control system for pallets.
Exactly like that. The loader looks at their screen and it shows a clear, color-coded visual. It literally instructs them, pick up this specific pallet from aisle 4 and place it exactly in this left side slot on the floor of the trailer.
That is so simple.
Yeah, the software has already pre-solved the physics of moments. If the loader just follows the diagram, the load is guaranteed to be 100% axle legal across every state line. Plus, it's packed to the absolute maximum payload and stacked so nothing gets crushed.
That is brilliant. Taking the anxiety of those hefty fines out of the equation just completely changes the dynamic on the dock. Workers don't have to guess, and companies don't have to artificially slash their payload capacity just to build in a safety buffer.
It's a win-win.
But, math running in a server room is one thing. Testing these genetic algorithms in the real world, especially with high-volume freight, is where the rubber meets the road.
Absolutely.
And the sources feature this massive case study with Riviana Foods that really proves the concept.
Oh, the Riviana case study is fantastic.
Yeah.
So Riviana is the largest rice producer in America, and this case study zeroes in on their massive operations in Memphis, Tennessee.
Just a huge facility.
Yeah. To give you a sense of the sheer volume, they are shipping over 10,000 truckloads a year out of that single facility.
10,000 truckloads. And they were dealing with what the study calls a mixed weight puzzle. Because Riviana ships a massive variety of products on the same truck, right?
Right. You've got extremely dense, heavy 20-pound family bags of rice combined with pallets of those very lightweight single-serve microwavable rice cups.
So relying on tribal knowledge with that kind of product mix, that's just a recipe for disaster. If a loader grabs the dense 20-pound bags first and loads them into the front of the trailer, they are packing an immense amount of weight into a very small footprint.
Which immediately throws off the sum of the moments.
Exactly. Here's where it gets really interesting. It's essentially a cruel game of Tetris. The loaders are dropping these pallets into place, trying to fill the visual space of the trailer, but they don't actually know the true weight impact of the blocks until the game buzzes and tells them they've loft at the weigh station.
That's a great way to put it.
Yeah, they were hitting the legal axle limits long before the trailer was physically full. They had all this empty space near the ceiling and the back doors, but they couldn't legally put a single extra ounce of weight on the truck.
Meaning they were stranding payload capacity on the dock every single day.
So frustrating.
And, the weight gap per truck might seem small in isolation, but multiply that inefficiency by 10,000 shipments a year, and you are bleeding millions of dollars in completely avoidable freight spend.
Just lighting money on fire.
Basically, yeah. And on top of the financial cost, trying to teach a new employee how to perfectly interlock those dense bags and light cups to intuitively balance the axles, that took weeks of frustrating training.
I can only imagine. So by deploying Auto02 to solve that cruel Tetris game for the Memphis plant, I imagine the cost savings on 10,000 shipments must have been pretty massive if they were finally closing that weight gap on every single trip.
The results were genuinely transformational. The AI solved the cube weight puzzle simultaneously on every load. It knew exactly how to distribute the heavy bags and light cups to perfectly balance the axles while utilizing every inch of vertical space.
And what were the actual numbers?
The Memphis plant saved over $1 million in freight costs per lane.
Wait, $1 million just from packing the exact same trucks smarter?
Just from packing them smarter. Furthermore, because the system provided those intuitive 3D diagrams on the RF scanners, they cut loader training time by 75%.
Oh, wow, 75%.
Yeah. Brand new operators were hitting peak productivity in days instead of taking weeks to absorb the tribal knowledge of rice density.
That's incredible for turnover.
It really is. And from a purely financial perspective, the most impressive metric is that Riviana achieved a full return on investment in just 90 days.
90 days. The software paid for itself in a single quarter.
Exactly.
It effectively took all of that vital institutional knowledge, which used to walk out the door every time an experienced loader quit, and just embedded it directly into the code.
It transformed a highly volatile, human-dependent task into a repeatable, flawless process, shift after shift, regardless of who is driving the forklift.
Well, optimizing a single truck leaving the Memphis plant is a huge win, obviously, but supply chains don't operate in a vacuum. A perfectly loaded truck on the dock is practically useless if the broader network feeding it is in total chaos.
That is the crucial next step. Supply chains are deeply interconnected ecosystems.
Right. Because if a company flawlessly packs 24 trucks on a Tuesday, but their system erratically demands only 3 trucks on a Wednesday, the resulting whiplash destroys their relationships with transportation providers.
It's a nightmare for carriers.
I mean, you can't just call up a trucking company, demand 24 trucks for today, 3 for tomorrow, and expect them to give you reliable service at a good price.
No, carriers absolutely despise volume volatility. If a carrier has to suddenly scramble to source 24 empty trucks for a shipper on a Tuesday, they are forced to drive trucks empty from surrounding cities just to meet that sudden spike in demand.
And those empty trips have a name.
Yes, those empty transit miles are known in the industry as deadhead miles.
Deadhead miles.
Deadhead miles consume fuel, require driver wages, and generate zero revenue. The carrier simply takes the cost of that massive inefficiency and bakes it directly into the premium rates they charge the shipper.
So we really have to zoom out to the whole network to see the complete picture here. The ultimate max load strategy outlined in our sources is actually 1-2 punch.
Right, the 1-2 punch.
You have Auto O2 optimizing the physical trailer on the dock, but upstream from that, you have a companion AI called Level Load.
Yes, level load. It operates as the network capacity planner. While Auto 2 is calculating the physics of a single trailer, level load is analyzing the mathematics of the entire supply network.
Looking at the big picture.
Exactly. It looks 30 days ahead at inventory forecasts, production schedules, and consumer demand signals, and it actively smooths out the shipments.
So it identifies those artificial spikes, often caused by things like end-of-month sales quotas or batch ordering, and just flattens them.
It flattens the curve, yeah.
Instead of that chaotic 24 trucks on Tuesday and 3 on Wednesday scenario, Level Load redistributes the volume. It looks ahead and determines that some of Wednesday's less urgent inventory can ship early on Tuesday, and some Tuesday's surplus can safely hold until Wednesday.
Right, so it engineers a smooth, predictable flow of, say, 13 trucks every single day.
Which the carriers must love.
Oh, they do. By mathematically smoothing the flow of goods, level load reduces daily variability across a shipper's network by 60%.
60% is huge.
And because the carrier now knows exactly what volume to expect weeks in advance, the shipper achieves a 97% first tender acceptance rate.
Okay, so that means 97% of the time, the very first, most cost-effective trucking company they contact immediately accepts the load because they can actually build it into their schedule without scrambling.
Exactly.
This brings us to how the 1-2 punch executes in reality. Level Load looks 30 days out and generates what the industry calls shell orders.
Shell orders, yes. Think of a shell order as a highly reliable reservation. Level load communicates to the carrier, I will definitely need 10 trucks next Thursday.
And the carrier locks it in.
The carrier locks it in. Level load has secured the physical capacity, but crucially, it does not immediately dictate exactly which pallets are going onto those trucks.
Maintaining that flexibility is so vital because a week is an eternity in retail supply chains. Like if a company commits to the exact inventory a week early, consumer demand could shift, and they might end up rushing product to a warehouse that no longer desperately needs it.
Right, the brilliance of the strategy lies in holding the capacity in reserve. Then, right before the actual ship date, when the inventory data is perfectly up to the minute and demand signals are crystal clear, Auto 2 steps in.
The second punch.
The second punch. It takes that reserved truck and mathematically fills it to the absolute legal maximum using the most urgent, highest priority products available in the facility that very morning.
So you secure the cheap, reliable transportation weeks in advance, but you retain the agility to build the perfect, most relevant load at the very last possible second.
If we connect this to the bigger picture, this 1-2 punch demonstrates how cutting-edge financial optimization directly drives environmental sustainability.
Yeah, let's talk about the environmental impact.
Specifically, it's about the reduction of Scope 3 carbon emissions. Those are the indirect emissions generated up and down a company's entire value chain.
Right, and for major corporations moving physical goods, third-party transportation is almost always one of the largest contributors to their overall carbon footprint.
Absolutely. By eliminating network volatility with level load, a company stops forcing carriers to drive empty deadhead miles just to chase erratic schedules.
Makes sense.
And by calculating the physics of moments with Auto 2 to pack every trailer to its absolute legal maximum, you are physically removing thousands of unnecessary truck trips from the highway every single year.
You're moving the exact same volume of product, but requiring significantly fewer vehicles to do it.
Exactly. It drastically reduces Scope 3 emissions without the company needing to completely overhaul their logistics network or purchase a single new electric truck. They achieve massive environmental gains simply by eliminating the empty air.
So why should you, the listener, care about the intricacies of supply chain software, booking a truck, or mathematically balancing the axles on a trailer?
It's a fair question.
Because these hidden mechanisms dictate the reality of your everyday life. When a manufacturer utilizes this one-two punch, it prevents the supply chain from fracturing under pressure. It ensures that your favorite brand of rice, or whatever household staple you rely on, is actually sitting on the shelf when you walk into the grocery store.
And at a fair price.
Yes. Furthermore, the hidden carbon footprint of your weekly grocery run is significantly reduced, and those massive freight savings prevent unnecessary price hikes from showing up on your receipt.
It is a complete paradigm shift from reactive, siloed logistics to proactive, mathematically optimized execution across the entire network.
Well, we've covered some serious ground today. We started with the frustrating reality of the 40-foot California kingpin rule and how the seesaw effect inadvertently forces 90% of trucks to travel partially empty.
Such a massive inefficiency.
We broke down how replacing tribal knowledge with AI like Auto-O2 solves the physics of moments, translating complex math into simple 3D diagrams that allow companies to pack trucks to the maximum without breaking the law.
An execution compass.
Right. We saw it save Riviana Foods over $1 million by solving their mixed-weight rice puzzle, and finally, we zoomed out to see how level load smooths the network, securing the trucks early so Auto-O2 can pack them perfectly at the last minute.
The shift from guessing to calculating fundamentally changes the constraints of the physical supply chain.
But before we wrap up, there's a fascinating thread here worth pulling on. Everything we've discussed today revolves around AI working within the boundaries of our current human-designed world. It optimizes around standard 53-foot trailers and arbitrary regulations like the 40-foot kingpin rule. But those rules were designed for human drivers, manual loading docks, and traditional suspension systems.
Yeah, the constraints themselves are legacy hardware.
Right. So if AI can already perfectly calculate the physics of moments for static freight today, what happens in the near future when fully automated logistics networks and self-driving trucks take over the highways? Will AI eventually begin designing the physical dimensions of the trailers themselves?
Oh, that's an interesting thought.
We could see a future where the algorithms tell the vehicle manufacturers exactly where to place the axles on a new truck to perfectly synergize with the software's loading patterns.
It really raises a profound question about the future of infrastructure. I mean, will our legal regulations simply adapt to the software, or will the AI eventually redesign the physical hardware to render human-designed kingpin rules entirely obsolete?
Definitely something to chew on the next time you find yourself stuck behind a massive 18-wheeler on the highway. Hopefully in the future, you'll at least have the comfort of knowing the math guarantees it is actually packed to the brim. Thanks for coming along on this deep dive with us. Catch you next time.